everyone. Thank you for the nice introduction and the story. Today I will fast forward a little bit and go into the present with serverless. And I will discuss with you about Java and whether it's a good fit or not for serverless. My name is Andra Stefan. I am an engineering manager for Deloitte Technology Delivery Center. And I began my career about 10 years ago as a backend developer in the consulting area. So I've been involved in multiple projects with various technologies, various architectures that I got to analyze. When I started working for Deloitte, I was assigned to a project that wanted to build a serverless application using JavaScript. Back then I thought, why JavaScript and not Java? And that question stayed in the back of my mind. And 5 years later, I decided to make a research and see if in these days Java is indeed a good fit or not for serverless. So how many of you here have worked with serverless? Okay, quite a few. For those of you who haven't, I will make a brief introduction. Serverless is a computing model that allows us to build and run applications without managing the infrastructure, which is great because we can focus on the product. We can go from prototype to production to plan and scale. It's easy to maintain. We have cost efficiency because there is a pay-as-you-go plan. It's scalable up and down according to our demands. So it sounds great. I will further concentrate on the function as a service part because it's the most common serverless model. So what is a function as a service? It's basically a service that allows customers to run code as a response to events. It's a narrow-scoped function. It's a small modular piece of code that you get to run without caring about the infrastructure. So far it sounds great. It's a developer's dream. You know, you can focus on your code. You don't have to think about infrastructure. You don't think about budget limitations that much. But there's also a drawback, and this is the cold start problem. So what's the cold start? When you try to trigger a function, if there is no environment available, then the cloud provider will go to the init phase. In this init phase, it creates the execution environment, downloads the code, starts the runtime, and then initialize the function code. Then it goes to the invoke phase where it actually runs the function. If there is any environment available, then we have another case, which is the warm start, and then we don't get the init phase, we just go directly to the invoke phase and run the function. So this init phase, if it lasts too long, we have some latency and we have a problem with the cold start. And Java is being notorious for having long cold starts. So, looking at the trends in the serverless world, so first of all, I have to mention that it's very hard to find these numbers related to how much a language is used in the serverless world. I've extracted some reports published by Datadog, which is a cloud asset monitoring solution, and Serverless, which is a framework for AWS Lambda, and printed out this chart. So it's just a highlight, it's just an overview, but it's enough to see that Java isn't the first choice for serverless. Instead, JavaScript and Python are constantly interchanging their first and second place. And there is also another language, Golang, which is relatively new and is gaining more and more popularity. But we can see that Java is maintaining its third place as a language used in serverless. So in order to understand better these trends, we have to look at the language alternatives and what do these language provide and what do they do better. First thing, JavaScript. It's an interpreted language. So I'm mentioning interpreted because an interpreted language is usually faster to start. It might be slower to run, but it's faster to start, so it won't have such a big problem with the cold start. JavaScript is dynamically typed, and it's quite easy to learn if you don't get into very complicated things. So it's really easy to get started, write a function, get it into the cloud, run it, and here's your code in production. It also has many libraries, it has a vast ecosystem, so sometimes it's quite hard to pick the right library, but there's also a great community over there that can support you and guide you in picking that. JavaScript is also great with IO-intensive tasks because that's the way it was designed, so if you have to implement this kind of thing, then maybe JavaScript will be your go-to language. Then there's also Python, which is another interpreted language. In terms of readability, it's better than JavaScript, but it's as easy to learn as JavaScript. And it's getting more and more adopted in universities due to its easiness in learning. It also has a great support in data analysis, machine learning, AI, and all this part of data science. So the community is quite large, especially in universities, as I was saying. So if you want to implement something towards data science, then Python is a great choice. Then also we have Golang, which is a new language. It is compiled, so you might think that just because it's compiled, it would have the same issues as Java, but it doesn't. It's faster to start than Java. It uses less memory. It was designed for high performance, and they have created Go with an idea of simplifying development process. So if you're looking for this high performance but with better timing, then you should pick Go. It's a little bit harder to learn if you compare it to Python or JavaScript because it has a more rigorous structure and it's also statically typed. But this rigorous structure also ensures more security. So if you do care about security, then maybe you should pick something like that. What's great about Go is also that it has a robust standard library, so you can do many things without getting other dependencies or using a framework. But then what about Java? Because, we like Java. Java was built with the notion of running a server all the time. When you think about Java, you don't think about narrow scoped function that you will easily write and deploy and run. You think about servers running all the time. You think about how to avoid boilerplate code, how to use a framework to write easily code. You think about all the big legacy apps that have been around. So what's Java doing to get into the serverless landscape? Besides addressing the cold start problem, which we saw that it is a problem for Java and serverless, Java is trying to stay relevant in this cloud-native context. And it's trying this by getting new technology, such as a new JDK and different frameworks to developers to help us get closer to the cloud. I will start by presenting a new JDK. It's called GraalVM, and it's a highly performant Java development kit created to simplify building Java cloud-native services. It brings us the Graal compiler, which with a just-in-time compiler, can increase performance up to 55% with no code changes, which, if you think about it, it's great. Then there's also a nice thing about GraalVM. It provides the native image utility, which by using an ahead-of-time compiler, it's creating a native executable image. You won't need the JVM to run that. It's fully functioning by itself. If you think about this, it might not be the idea behind Java when you write it once and run it everywhere, because a native executable must be compiled according to the architecture where it's going to run. But then it runs with just a fraction of the resources needed by the JVM. It starts in milliseconds, so it basically has almost zero warm-up time. So if you think about this in the serverless context, then maybe you can go over the basic principle of Java. Of course, again, it sounds great, but it has some limitations. It's harder to compile because you have to target a certain architecture. Compiling also takes longer, and you also need to provide some config files for anything that's dependency injection, reflection, proxies, serialization. But if this helps you fight the cold start problem, then it's a good choice. Then we have a couple of new frameworks that also aim to bring Java closer to a cloud-native world. I will mention Quarkus, which was designed to build Java application in a cloud-native context, and it was tailored for GraalVM. So it has a first-class support for GraalVM native image. It's similar to Jakarta Enterprise Edition, so if you have some background with this, it might be easier to go to Quarkus. It also enables combining imperative and reactive programming. It has a good documentation, so it's quite easy to adopt. But if you come from the Spring background, there's also something nice out there for you. It's called Micronaut, and it's officially described as a full-stack framework for microservices and serverless applications. It's easy to make a shift from Spring to Micronaut because it has many familiar annotations, and I even discussed with some members of our developer community, and they do agree that it's a very easy change and shift that you can make. What's great about Micronaut is that it provides dependency injection and aspect-oriented programming with no reflection, meaning that it will start faster than Spring and it will have a minimalistic runtime. It's also great for database connections with Micronaut data. So if that's your use case and you come from the Spring background, then it's a really nice framework that you can adopt. Then you might be bound to use Spring. And if it's the case, then the good news is that Spring also tries to get into the serverless landscape. It provides Spring Cloud function that gives us adapters for most common cloud providers. And it also enables combining imperative and reactive programming. But it might be the case you only need a small framework. You need it to be cloud native, but you need just the dependency injection part, and you don't want to integrate a big framework. Then there are some options over there. I will just mention Avahin and Dagger, but there are many more. So if you search, you might find something that's good for your context. But if you're bound to use plain Java or Spring, there are some optimizations that you can make from a cloud provider perspective. There are pre-warmed instances that you can set. So any cloud provider will allow you to set a number of pre-warmed instances, which are functions that stay warm and are ready to react to your triggers. There are also strategies like keep warm strategy. With this strategy, you will have to trigger some functions from time to time just to keep them warm and have them available to serve your requests. This kind of contradicts the serverless concept of scaling upon demand and running whenever you need it. But if you do really need an optimization, then maybe you can also apply this strategy. And another great thing that AWS has released about 2 years ago is Lambda Snapstart. This feature, which is free by the way, it's taking a snapshot of your working environment, it encrypts it and stores it. So whenever you will need a new environment up and running, it will retrieve this snapshot from the database and restore it. So by doing this, it will ensure up to 10 times a performance improvement, which is great if you think that you don't have to change anything in your code. You can still use your old technologies if needed, but you will get almost a 10-time performance improvement. That being said, we're going back to the initial question. So, is Java a good fit for serverless or not? And of course, the answer is it depends. So it pretty much depends to your context. You have to analyze your context and figure out if Java is the best solution for you. And to do this, I've selected 3 main areas where you need to look. So you have to look at the project lifecycle. Are you in the greenfield phase? Because if so, then you still have time to explore. You can look at new technologies, you can compare them, and you can bring them to your project. You can be in a migration phase, and there you have to check the magnitude of your migration. Are you migrating a small part of your application? Because if so, then you should probably stick with your old technology stack. But if you're migrating the whole application or a bigger part, then maybe it's a good time to introduce something new. And you also might be in the feature development cycle, where you just add new features or new components. And then it's very important to keep the consistency of the tech stack. So I'm not saying it's wrong to introduce new technologies, not at all. You should look on the market and see whatever helps you more and bring them to your project. But you have to be careful to bring value, not chaos. So you have to maintain some ways of working and really care about the tech stack consistency. Another thing we should look into are time constraints. So if we have tight deadlines, then maybe we should probably stick with whatever we know better. So if you're a great Java developer and you know that you can deliver amazing solutions with Java, then go for it. Because with a tight deadline, maybe you don't have enough time to learn a new framework or a new language and perform as well as you would in the known one. But if you have time to explore and research, then do it, because you might find something that helps you more. Then last but not least, performance constraints. You might need to implement a latency sensitive application. So if you're in this kind of scenario, for example, with real-time systems or with user-facing APIs, then you really need to care about the cold start problem. So maybe then you will ask yourself if Java is good enough or not. Maybe you will go with the native image. But there might be the case where you just have to implement background processing tasks. like synchronous task, analyzing data, generating reports. And then we don't care that much about this latency, this cold start issue. So then you are free to choose whatever technology helps you more with that actual processing. Then a natural question that arises is, how can I decide what's better for me? So the answer is that you need to analyze your context. And I've also extracted some steps that usually help me in the decision-making process. First of all, you have to look into the project requirements. You have to analyze it. You really need to understand the requirements and also the project needs, the limitations, the budgets, the timelines. Then you should also look in your team, do a team analysis, see what the seniority level is. Do you have experts that could deliver amazing solutions? Do you have mentors that could help your team members grow and learn new technologies? You have to look into their desire to learn. Is there a desire to learn something new and to explore, or is there a desire to deepen their knowledge on something that they already know? You also have to look at the skills and the tech stack that they've used before, because they might be familiar with something that you're trying to introduce. So this would be great. The next step would be the research one. So you should research. I really encourage you to research, whether you're working in a product company or in a consultancy company or in a startup. It's always good to research, to analyze the new technologies, the trends, and see whether something new came up and could help you. Because 5 years ago, we didn't have all these new technologies and new frameworks, so Java wasn't such a great solution. But now, when I see all these possibilities, I can think again and go with this language. It's also very good to check the community's opinion, whether it's the community you have back in your company or whether it's the larger developer community. It's really good to have a look and see if someone has encountered a relatively similar context, if they can share some experience, if you can learn something from the community. And the final step would be to test it, but test it in a relevant way for you. When I first started about this idea with Java and serverless, I wanted to make a comparison between frameworks or maybe between languages and come to you with some numbers. But then I thought that maybe these numbers won't be relevant for you. Maybe it won't be relevant for you to see how a hello world printing function behaves in different situations. So you have to look at your context and create some tests that are relevant for you. Try to build a reduced scaled app with the basic functionalities of whatever you are trying to obtain. Try to make a POC, for example, and then check it with multiple technologies, with different languages, and extract your own numbers. And then you will know what to choose. So you have to remember that there is no language battle, there is no technology battle, there is no perfect tool, but there is this context that will guide you in finding whatever that fits you the most and whatever it would help you the most in your project. So stay curious and have a look out there on the market, analyze the technology, and be really careful to your context and try to get the most of it. Thank you very much for your attention, and if you have any questions, I'm happy to answer.
Big round of applause, first of all. Congratulations. Great presentation, loved it. So, questions? You take one question. First come, first serve. All right, I have one. Oh, okay. Mike goes to him.
Hello. Did you have the migration experience at your career? I don't know, and switching the languages from Java to another, and what the main points why?
So yeah, I had both experiences. I had to switch languages, and I did that in multiple projects. So I switched from Java to JavaScript to Kotlin, and what can I say is that the project helps you a lot. So it helps you to have a hands-on experience, and then go read something, and it's great that you can expand your knowledge. And what's great about learning new languages is that you can then compare them and see have a better, bigger picture. And then you also have some favorites. You like some, you dislike some. And about the migration part, yes, I had this experience, but not in the serverless context. We worked on a project migrating from on-premise to cloud, so that's the experience I had. And what can I say is that it can bring some interesting challenges, because the environment is different and the challenges are different. So if you have the lift and shift context, so you just grab the code and just adapt it a little bit to make it work on in a new context, then you'll face some very interesting challenges, and you have to be prepared for many constraints, and you have to be prepared to adapt your code.
But I mean, it's really hard when you have a developer team and you need to migrate a lot of data, like to change your environment and so on. So it could be really difficult on this point of development of your application. When you just starting, of course, it could be easy, but not when you are working on project.
Yeah, that's right. So migrating is hard. So this migration I'm talking about, it was a project itself. So it's not easy. At that point, we haven't switched the language. You haven't changed the language or the tech stack. So it was a big migration, but keeping the tech stack, because we had to run in parallel in both on-premise and in cloud. But the challenges, yeah?
Thank you so much. This is
Okay.
turning into a conversation. It's
Yeah.
exactly the type of conversation that you can take after the presentation outside of the...
Yes, thank you. So if you want, yeah, we can
Excellent.
connect outside.
You shall, definitely. Thank you so much again. Representation of Big Brother Class for Andra.